Dear students, this is our 25th lecture on medicinal chemistry and third lecture on antibacterial drugs. In the previous two lectures, on lecture 1 and 2, I have given you an idea about what are antibacterial drugs and what kind of drugs are included in this group of drugs. For example, antifungals, antivirals, antiprotozoals, and antibiotics, they are included in antibacterial drugs. And further in lecture 1 and 2, I have described about the mechanism of action of these antibacterial drugs on the bacteria. And in lecture 1, I have described about inhibitors of cell wall synthesis, that how these antibacterial drugs they act on the bacteria. Similarly, in lecture 2, the description about inhibitors of protein synthesis, inhibitors of cell membrane synthesis, inhibitors of nucleic acid synthesis, and inhibitors of metabolic pathways have been described. Now, in this third lecture, we will discuss how some of the commonly used antibacterial drugs they can be synthesized in the laboratory. And among them, first antibacterial drug which we will discuss is furazolidone. Furazolidone is having this structure. This is synthesized from starting from 2-hydrogenyl ethane 1-ol. So you can see that this starting material is having a hydroxyl functional group as well as a hydrazine functional group. So when this is reacted with diethyl carbonate, what will happen? This hydroxyl group will act as a nucleophile and will attack the electrophilic carbonyl group with the elimination of ethoxy from here, H from here. So ethanol is removed from here with the formation of an ester linkage between the starting material and diethyl carbonate. Then in the next step, this nitrogen will also act as a nucleophile and this will attack this carbonyl so that a cyclic compound is formed. So 3 amino 1 3 oxazolidine 2 one is formed. And in the next step, this amino group will interact with the carbonyl group of benzaldehyde to give us this type of hydrazone is formed. Then this hydrazone on reaction with uh, 5-nitrofurfuryl, basically what happens is this aldehydic group will react with this nitrogen with the elimination of benzaldehyde from here. Basically, this is replacement of one carbonyl group with another carbonyl group. So this is how furazolidone, which belongs to oxazolidone, zolidinone group of antibacterial drugs is synthesized. Then next is nalidixic acid. Nalidixic acid is synthesized from pyridine derivatives. So when 6-methyl pyridine 2 amine is reacted with diethylethoxymethylidine propiondiovate. So this type of diester is reacted with pyridine 2 amine. What happens is this amino group will act as a nucleophile and this will attack this electrophilic carbon with the elimination of ethoxy group from here and H from here. Basically, ethanol is removed with the formation of a carbon nitrogen bond at this place. So this substituted product on heating undergoes cyclization and aromatization. Basically, when this is heated, what happens is hydrogen at this ortho position and ethoxy from here. There will be formation of carbon-carbon bond at this place with elimination of ethanol. After this, first cyclization has taken place, then aromatization. This hydrogen is transferred from this nitrogen to this oxygen. So this bond will go to this place, this will go to this place, and this will become hydroxyl. So this is how aromatization will lead to the formation of this ethyl ester of 4-hydroxy 7-methoxy 4-hydroxy 7-methyl 1,8 naphthalene 3-carboxylic acid. So ethyl ester of this carboxylic acid is formed, and this will undergo hydrolysis in the presence of sodium hydroxide. So under basic medium, this ester group will be hydrolyzed to carboxylic acid, and then with ethyl iodide, N-alkylation will take place at this nitrogen with the movement of this hydrogen from here. This will go to this place, and ethyl will get attached to this, and HI will be removed. So this is how nalidixic acid is synthesized. Nalidixic acid, this has a bactericidal or bacteriostatic effect. Bactericidal means it will kill bacteria, or bacteriostatic means it will inhibit the growth of the bacteria. So this will act either as bactericidal or bacteriostatic based on the sensitivity of the microorganism and the concentration in which this drug is given. Nalidixic acid is effective against gram-negative microorganisms like colon bacillus, salmonella, shigella, proteus, and Flanders bacillus. The other names of this drug, they are Nigram, Navigramone, Euroligin, Eurogram, and Vintron. The next antibacterial drug which is most commonly used is ciprofloxacin. Ciprofloxacin is a broad-based antibiotic of fluoroquinolone series, and this is used to treat a variety of infections. And as I have told you in the second lecture also, that this is active against both gram positive and gram negative bacteria, and mechanism of action is that this inhibits the DNA gyrase, and type 2 and type 4 topoisomerase which are necessary to separate bacterial DNA. Thereby this will inhibit the cell division in case of DNA. So this drug was invented by Bayer in 1983 and marketed in 1987, and this is also included in the generic drug of essential medicine list of WHO in 2015. The original synthesis by Bayer was given by Klaus Grof, starting with 2,4,5 trifluorobenzoyl chloride. So when this was reacted with ethyl 3 diethylamino-propyl 2-enoate, so this amino ester was reacted with 2,4,5 trifluorobenzoyl chloride. Basically, you know what will happen. This will react with this acidic proton with elimination of HCl from here, and we will get this type of ketoesteramine. Then this will react with cyclopropylamine with the elimination of this cyclopropylamine will attack at this carbon with the elimination of dimethylamine from here to give us this type of intermediate product. So this cyclopropylamine derivative is formed. And when this is reacted under basic condition in presence of potassium carbonate and DMF, basically cyclization will take place at this place. This will act as a nucleophile, so aromatic nucleophilic substitution with the elimination of chlorine from here and H from here, we will get this type of ethyl 1 cyclopropyl 6,7 difluoro 4-oxo 1,4 dihydroquinoline 3 carboxylate will be formed. So basically dihydroquinoline derivative is formed, and this quinoline derivative then reacts with the piperazine in presence of HCl. Here the substitution will take place with the elimination of F from here and H from one of the nitrogen on piperazine, and we will get ciprofloxacin hydrochloride as the product. So this was the first industrial method to synthesize ciprofloxacin, which is very commonly used as an antibacterial agent. Then some modifications in the first synthesis, they were also done by Bayer's, which is called as Bayer's second synthesis. So here basically the starting materials have been modified. You can see that in case of first method we have used all the three fluorogroups, and in the starting material over here two of the fluorogroups they have been replaced by fluorogroups. So 2,4 dichloro 5 fluoro benzyl chloride is used, and when this is reacted with diethyl malonate, the corresponding diester beta keto ester is formed. This beta keto ester, first this diester is formed, and this diester in presence of acetic medium on heating undergo elimination of one of the ester groups, is converted into beta keto ester, and this beta keto ester on reaction with triethyl orthoformate in presence of acetic anhydride gives us this type of enol ether. So basically this the hydrogens present on this carbon, they are very acidic hydrogens due to the presence of this keto group and this carbonyl group. So this will generate a carbanion over here, and that carbanion will attack this carbon of the triethyl orthoformate. Ethoxy group from here and H from here will be eliminated. One ethanol part will be eliminated, and then another hydrogen from here and ethoxy from here. This will generate a carbon-carbon double bond, and this is how we will get this enol ether from beta keto ester. And this enol ether on reaction with cyclopropylamine will give us the corresponding cyclopropylamine derivative. So basically this will attack as a nucleophile at this place, and H from here, ethoxy from here, ethanol will be removed, and we will get this derivative. And then rest of the method is same as we have seen in the first step. Only difference is this under basic conditions will undergo cyclization H from here and Cl from here. In the first method, here we were having fluorine, but here HCl will be removed for the cyclization process. And then last method is same as we have seen in the previous method. So H from here and Cl from here, we will get ciprofloxacin hydrochloride as the product. The next is norfloxacin. Norfloxacin is similar to uh, ciprofloxacin. Only difference is that in place of cyclopropylamine, we are using ethylamine. So here 3-chloro-4-fluoroaniline is reacted with the same reactant which we have used in the first method of ciprofloxacin, diethyl ethoxymethylidene propane diovate. So here this will act as a nucleophile. With the elimination of ethanol, we will get this type of substitution product, and this substitution product in a similar way undergo on heating will undergo cyclization and aromatization in the same manner as we have seen in case of ciprofloxacin. So in the first step, H from here, ethanol from here, a carbon carbon bond will be formed over here, and then aromatization, this bond going to this place, this bond going to this place, and this bond going to this place, with H shifting from nitrogen to oxygen. So we will get ethyl ester of 7-chloro 6-fluoro 4-hydroxy quinoline 3-carboxylic acid, and then this will undergo hydrolysis in the same way under basic condition. In presence of sodium hydroxide, this will undergo hydrolysis, and then this will react with ethyl bromide and alkylation will take place, and we will get this type of product. And this on reaction with piperazine will give us norfloxacin as the product with the elimination of this chlorine from here, H from here. So this is how we will synthesize norfloxacin, which is again belongs to fluorinated quinoline category of antibacterial drugs. Then is dapsone. Dapsone is synthesized from 4,4-diamino diphenyl sulfone. This is dapsone 4,4-diaminophenyl sulfone. This is synthesized starting from 4-chloronitrobenzene. So 4-chloronitrobenzene on reaction with sodium sulfide will give us this 4,4-dinitrodiphenyl thioester, and this thioester on oxidation with potassium dichromate in sulfuric acid is converted into the sulfide is converted into sulfone, and this sulfone then undergoes reduction in presence of SnCl2HCl, and these nitro groups, they are reduced to minor groups to give us dapsone as the product. The process of synthesis of this drug is very simple. So first is sulfide formation, then sulfide undergo oxidation, and then these nitro groups, they undergo reduction. So this is a oxidation reduction process. The next is para-amino salicylic acid. This para-amino salicylic acid is synthesized from 4-amino-2-hydroxybenzoic acid by Kolb reaction. Basically, this is a single step reaction. When meta-aminophenol is reacted with potassium bichromate, bicarbonate in presence of carbon dioxide, uh, while heating under moderate pressure of 5 to 10 atmosphere, the formation of this para-amino salicylic acid takes place. Then isoniazid. This is synthesized by reaction of ethyl ester of isonicotinic acid with hydrogen, simple process of formation of an ester. So this hydrogen will act as a nucleophile, will attack this carbon of the carbonyl with the elimination of ethanol, ethoxy from here, H from here. Ethanol is removed and we will get isoniazid as the product. Then is ethionamide. Ethionamide is having this structure. This is a derivative of isonicotinic acid, and this is synthesized from condensation of diethyl oxalate with ethyl methyl ketone in presence of sodium ethoxide. So this is a simple condensation reaction. Basically, in presence of base, a carbanion will be generated at this place, and this will attack this carbon of the carbonyl with the elimination of ethoxy group from here. So H from here, ethoxy from here. Ethanol will be removed, and we will get this type of propionyl pyruvic acid ethyl ester is formed, and this on condensation with cyanoacetylide in presence of pyridine leads to heterocyclization to give us this type of pyridone derivative, and this pyridone derivative undergoes hydrolysis. So hydrolysis will convert this ester into carboxylic acid. In the presence of HCl, this cyano group will be removed. Uh, HCN is removed, and we will get this 4-carboxy 6-ethyl 2-pyridone is formed. And this 2-pyridone derivative on reaction with mixture of POCl3 and PCl5, this will convert this amide into this type of chloroisonicotonic acid. So 6-ethyl 2-chloroisonicotinic acid ester is found. Then a reduction of this with hydrogen and palladium will replace this halogen with hydrogen. So we will get ethyl ester of 6-ethyl isonicotinic acid. This is formed, and this on reaction with ammonia in phosphorus pentoxide is converted into cyanide. So this nitrile of 6-ethyl isonicotinic acid is formed, and this 6-ethyl isonicotinic acid nitrile on reaction with H2S gives us ethonamide as the product. So basically this will add H2S will add to the carbon nitrogen triple to give us ethonamide as the product. Then is ethymbutol. Ethymbutol uh, is used as drug in SS enantiomeric form, whereas this drug has 4 isomers. Out of these 4 isomers, only this enantiomer is biologically active. The synthesis of this drug can be achieved in different ways, and one of the general method is that it is synthesized from nitropropane. So in the first step, nitropropane undergo uh, oxymethylation using formaldehyde, and gives us 2-nitrobutanol, and this again is reduced. Nitro group is reduced in presence of hydrogen and nickel, and this will be converted into amino group. Then this amino alcohol is reacted with dichloroethane in presence of sodium hydroxide to give us S as an isomer of ethane butyl as the product. So first racemic mixture is formed, which is resolved with L-tartaric acid to give us 2-amino-butanol as the product, and this 2-amino-butanol then react with uh, 1,2-dichloroethane in presence of sodium hydroxide to give us SS ethane. Whereas another method is that this can be synthesized from R2-1 butanol on reaction with 1,2-dichloroethane in 42%. Then another method was developed by Butola, again from +2-1 butanol. So this on reaction with this diester rather, uh, oxazolidine, oxazoline. Uh, this is synthesized from the condensation of this diester and amino alcohol to give us this intermediate, and this alcohols they are converted into corresponding chloro groups on reaction with thionyl chloride, and then these chloroderivatives they undergo cyclization in presence of basic medium, that is potassium hydroxide in methanol. On refluxing for 1 hour, they are converted into this bridged oxazoline, and then this bridged oxazoline undergoes reduction in presence of lithium aluminum hydride under aqueous sodium hydroxide, and this carbon nitrogen double bond is converted into carbon nitrogen single bonds, and then this undergoes further reaction in presence of lithium aluminum hydride or sodium sodium borohydride with the breaking of this carbon oxygen bond to give us ethyl butyl as the product. So these are the references which have been used for preparing this lecture. Thank you very much.